Have you ever gotten frustrated with yourself because a project competition didn't go the way that you wanted it to go? Well, a lot of times it goes back to the planning. There's an saying that says prior planning prevents poor performance. And a lot of times we have to go back to the root. And especially when we have a team, we got to ask ourselves, did we have a Gantt chart, or do we even know what it is? So, my name is Shanika Bridges Matthew. I am an engineering and technology teacher. I also teach graphic design, among other things. And I'm also a TSA advisor, a National Society of Black Engineering, high school advisor, Vex Robotics. I've been drama club, I've been dance, all the things. This is something that can be used in anything. Gantt charts are used in the real world, in the working world where people get paid. They can be used at your house. They're just something that you can definitely use. So they help you to plan, schedule, and manage projects. And now this is geared towards engineering projects because I am an engineering teacher for high school, and I'm also a technology student association advisor. So that's TSA, and it's 300,000 people globally that are in TSA. So of course this would apply to more than one person. So anyway, I wanted to give you a framework of how a Gantt chart looks, and it is pretty much just a visualization. You could do this, in a notebook. You can make your own, but it's really just a bar chart, right? And so it's a project timeline that gives you a visual of when you will be able to get things done. So you would have on there your design process, like in one column, like the things that have to get done, those tasks, which is every action needed to complete the project. Then you would have a timeline, like how long do we have, right, to complete it? Is it a 4 week project? Is it one day, a 30? Sometimes we do little challenges in class. It could be a 30-minute challenge, but you still want to need to go through the process. It could be a 3 month or year or multi-year project. Now, usually for students, we won't go past 3 months, and that's usually for TSA type projects. But I try not to keep our projects more than 2 weeks. Sometimes they turn into more than that. But so you have a timeline. Each task starts and ends. You have a duration, how long each task takes. Then you have a sequence, which task depends on the other, and then your progress. You have to update it. How much of each task is done, and somebody on your team, preferably the project manager, every team should have one, should be updating this. So we talk about the anatomy of a Gantt chart. So as you can see here, again, we talk about the task. So again, if we're talking about the engineering design process, we know that we define the problem. Then we go into our research, which includes brainstorming, because there's different steps in the engineering design process. So sometimes you have a longer 12 step, you have a 6 step, just depends on what framework you're using, but this is generally what you would have in those projects, right? Um, defining requirements would cause you to ask questions. It's not just a one track, one sentence thing. Um, you want to show the vision of the project, the issue of the project, and then something that how you're going to solve it. You need to talk about that, okay? Um, research that would include brainstorming some ideas, then going out into looking at peer reviewed things or things that have worked for people or similar things that you're thinking about. And so that's going to take a while, and it's not people, the projects that I've seen in the past that did not do well, they skip over this main step. Also, sketching and design, you have rough sketches that you can draw out, but you also need to use Onshape, uh, Revit, if you're doing architecture. It's so many different programs, and I'm not thinking of all of them, of course, but we use Onshape because it's web based and CAD program. So CAD, some type of CAD program to write the vision and make it plain, and something that you can share across your group. And then you're building your prototype. That is tedious, right? A lot of times students just want to jump into the build. They don't want to, and of course with the design process you can do that, but you're wasting time. You're wasting time, especially if you don't do your research. You don't see the materials that you need. You don't do your bill of materials list. That's just a in some game. You're not going to do well. Okay. And test and refine. Now, a lot of times kids turn in prototypes and they don't turn in a full project. Why do I say that? Because they don't spend a lot of time doing the first four things, right? They don't spend a lot of time on the other things. They just jump to the bill and then they just turn it in. And that's, you're not going to win anything that way. It's just an end sum game. It's not going to work. A zero sum end game, right? So you want to test it out. You want to do surveys. You want to make changes based off of feedback, and then you want to present your results. And mind you, no project is ever done. So once you do that, you still may have to go make changes. So it's iterative process. It goes over again. Okay. So engineers use Gantt charts because they need to see the big picture. They need to see all the tasks and deadlines in one view and no surprises. If you're talking to clients, your clients need a visual. You need to be able to break it down to where they understand it. You got to understand how to catch problems early and identify tasks that might run late before they do, because the tendency to run late is almost 100% if you don't put kind of some type of constraints on it. And if you're trying to deal with clients in this very competitive world, you're not going to stay in business long if you can't stay within budget and stay within the deadline. Managing dependency. So you got to know which tasks must finish before the others can start. If you jump into the build phase, you just start tinkering and building, and you don't do the correct things with the research and defining your problem and all the things and figuring out your criteria and constraints, you won't get anything done. Also, everybody on the team needs to know what's going on and where they are in the project. Okay. That is so critical because some teams it might be people working on multiple projects. They may be, I wouldn't say one trick ponies, but they may be specialties, specialize in the electrical, or they may specialize in the build, and so they may be working on different stages of different projects. So they need to know how to access the same plan and know what their role is, and then track progress. uh, you need to fill in your bars as work gets done and have an instant way to update. Now, this should be easy because in 2026 we have a lot of cloud-based programs where you could do this, but it does need to be updated. So whoever is the manager of the project and the person over them, they should be able to see, they shouldn't have to question where you are in that project. And then meeting deadlines, clear ownership and timing reduces last minute chaos. And as students that turn in, we have students that turn in over 50 projects a year over. Um, the the reason why some of them get disqualified or just don't make it to where they thought it should make it, even though it's beautiful, is because you just did not meet the deadline, or you did something at the last minute and it's obvious. It's very obvious. And people who judge things and grade things can see that. So remember, if you don't plan the work, you'll work without a plan. That happens a lot. That happens a lot. So how do you build a Gantt chart? So there are 6 steps that you can do, and you can actually do this on blank paper. You don't have to necessarily have a computer. However, the beauty of the computer is that it can easily be shared and updated, right? You don't have to start all over from square one like you do when you're drawing. So you want to first write down all the tasks that you have to do, and you want to be as specific as possible. So kind of think of like a grocery list, but this is a grocery list for design. So you got to think like if you're doing something as big as an architectural design, and you have to, your task is to build a barn dominium. I know that was a thing for TSA Nationals recently. What are all the things that go into a barn dominium? What are all the tools that you need? Um, what is your vision for the barn dominium? Have you researched? Do you even know what it is? Once you make it, what type of furniture? What does the landscape look like? What does the plumbing plan look like? What does the electrical plan? All of those things, and then you have to think about all the key ingredients for those things. A lot of people don't go deep into that. Okay, Estimate duration. So how long will each task realistically take? Build in a buffer, which is building in time because things always take, I would say, 2 to 3 times longer than you expect. Lord knows I know. I know, and this is something I struggle with too because I'm like underestimate the time, and sometimes you can hyper focus on something, or you can get into doom scrolling, and just the time will just not be your friend. Next, you will find dependency. So you want to find which task must finish before another can start, and you have to make those relationships. You can't test and evaluate something that's not there, right? So you can't be on that step when you're supposed to be on that step, but you're not finished building. And then you want to set your timeline. You choose your time scale. You want to do minutes, you want to do hours, days, weeks, or months based on your project length. Now, I'm going to be real with you. If you are doing something like animatronics is robotics, art, electronics, all together, all the things. So if you're good at robotics and you're good at like designing, which is would be an artsy type thing, that is a wonderful competition to do, but it is tedious because not only that you're telling a story with the animatronic figure, but you're also got to understand mechanics and electronics and hydraulics, pneumatics, and those things you may not know. You have to take the time to research. Also, think about animatronics is used a lot in the movie. So if you think about any type of, especially sci-fi movies, right? Or if you go to like an amusement park and you see like the Bumblebee, which is with the Transformers cars, the Jurassic Parks, things of that nature. That's what you think about. So that is not something that you're going to be able to do overnight. I don't know anybody, and especially as a team. So you have to really set your timeline for a good amount of time. It's not going to take you a month. It's not going to take you 2 months. It's probably going to take at least 3 months. So you want to really sketch that time out and draw the bars. So for each task, you're going to draw, this is number 5, a bar starting when it begins and ends and when it finishes. Okay. So that is very important. And you also want to be able to update as you go. And again, that's why you want to do it like when a lot of people do it in you could do it multiple ways. You could do it in PowerPoint, you could do it in Google, Canva, you could do just as long as you have the like a rectangle where you could just move bars around. You have to figure out how to do this digitally so that you won't continuously have to erase and go back and with the pencil or the pen or whatever the case may be. And again, update as you go. So fill in progress as work is completed. Okay, so if your teacher or advisor asks you where are you on this project, they should be able to see visually with the Gantt chart where you are and also evidence that you provide. So again, when you're reading the Gantt chart, the person that's reading it should understand from the bar length how long that task takes. Now, if I look at something and you're defining the problem and it's been 4 weeks and you're still defining the problem, that is a problem. Okay. It should not take that much time for that particular piece. Now, research, building, those things are expected, right? So just kind of think about common sense. Also, your bar position when the task happens. Left is on the earlier side, and the right is the later side. So you should know, just depending on the design process, where things should lie. There will be some overlap. So that's going to be when some things are happening simultaneously, and that can actually happen. I don't necessarily know if you should be also defining your problem and, you know, uh, I say building, right? I feel like I can see defining your problem and researching at the same time because you may go back and tweak that problem statement. So gap between bars, that's your waiting time or dependency that one must finish before the next one starts. So if that something is not finished, then you might have a gap between the bars. Filled versus empty bars. So a filled portion equals work completed, and an empty means work remaining. And then your critical path, that's the longest sequence of dependent tasks, delays, um, for the whole project. So some common Gantt chart mistakes. When you don't spend the time fully fleshing out your bill of materials, the things that you know you need, your ingredients, um, your tasks will become too vague. So you want to break big tasks into specific measurable actions. Again, something as big as an architecture project, again, if you have a team of 4 to 6 people on that type of project, you have to sit still and break everything down. You have to break the rules down. You have to read the rubric and break it down. All the things that it's asking you. And those sometimes those rules and rubrics are 10 pages long. You have to sit there and read and comprehend and reread and comprehend. Ignoring dependency. So not understanding like if this doesn't happen, this next thing doesn't happen, right? So just think about if we go on a trip. Um, right now I'm at nationals in DC. Now I didn't take any students this year because some people did not pay by the deadline. So that's a dependency. If you don't pay by the deadline, then you're not going on the trip. I can't pay the hotel and whoever else I need to pay. So if you ignore my communication about the trip and you don't pay and you think I'm supposed to pay, and it's not going to get done. So you want to make sure when you're doing a project, you want to map out which task must finish before others. So if that task doesn't finish, it's just not going to get done. Unrealistic durations. Again, that goes back to what I was saying. Like you should not be spending all your time on the brainstorm and then let's say you have 4 hours to do a challenge, right? I don't really call it a project, but this is a 4 hour project and you have to go through 6 steps. First step is defining a problem. The next is your research and your brainstorming. Well, I know that you're going to need at least 2 hours to research and brainstorm. Ask the person who created the project, and you only spent 20 minutes on it. Okay, that doesn't work. That makes zero sense. So you want to make sure that you add buffer time for any unexpected delays, because that happens on every project. And then people get into sidebar conversations, right? Never updating the Gantt chart. That is a big no-no, especially when we're dealing with classroom projects, TSA, real world projects. And again, other people they are looking at it. The teacher needs to move on to the next thing, so they put your grade in, and the parents want to know what your grade is. They want to know how you're doing. And if you're still stuck on the same thing, that means you're not doing anything. Okay. So you want to review and update your Gantt chart at every project check-in. And then last but not least, another Gantt chart mistake is every task in one long line. Every task should not be in one long line. You work in parallel when possible if it saves time. Okay. So if we were talking about TSA projects, and a lot of the classroom projects we do are TSA projects, I may shorten them because it just may not be conducive for us to do in class the whole length of it. But I'll say 50% of the projects in the class are going to be some type of origin comes from TSA because we have the rights to do it because we're affiliated and we everybody in the class is part of it. So every serious engineering project has a schedule. Okay. So TSA judges look for evidence of planning. And that's just not TSA, that's NSB, National Society of Black Engineers, that's Vex Robotics, every organization, nation builders, they're looking they're looking to see if you're planning. The kids that win are the ones that show that evidence. They show that evidence in their portfolio and they show it when they're speaking. So I've interviewed hundreds of students, if not thousands, over the years, and I can immediately spot when somebody's lying, right? So research and define. You want when you're in that stage of the project after you've gotten over your defining your problem statement and all the things, you should be able to do a literature review. Your problem statement is in there, and your criteria and constraints go in that particular thing. So you're defining your problem, you get into your research, and then you do all of those things. And then your ideation and design would be your brainstorming, your sketches, your CAD drawings, and your design selection. Your build and fabricate would be materials that you need, your materials procurement, how to get those, your construction and your assembly. And then your test and evaluate would be testing against certain criteria, collecting your data, analyzing it, getting feedback from people, their opinions, incorporating that into your project design, redoing it. And so refining and iterating, redesign based on the test results that you got back and additional bills. Okay, so that right here, this is like gold. Okay, all these take time, but like I said, you have to like do the math. It's STEM for a reason: science, technology, engineering, and math is at the end. But do the math, okay, and then document and present. So you need a written report, presentation preparation, and practice run. So remember, start your Gantt chart. If you're working on a TSA project, and this is one that you take the state or even nationals, because the same things you take the state, you take the nationals, but you're going to revise it to make it want to win, right? Uh, is the competitions are closer than it looks. But if we're doing something in the class, and let's say Miss Matthew tells you, I'm me, to you got a challenge. Okay, but I want a Gantt chart before this challenge. It's a classroom challenge. The challenge is going to be lasting within the duration of the class. I still want you to go through this as best you can, right? Just to get you used to going through this project, right? It might be only a 30-minute challenge, but within the 30 minutes, you need to go through all of these steps. So that's how we do those adaptations. So now it's your turn. You need to pick up your Gantt chart template and plan your project. And again, you can practice this at home or in the classroom. Now, if we're currently in the classroom and I'm playing this video or I'm going through this presentation, I want you to practice this on your own paper. I want you to list every task and be specific. I want you to estimate how long each one takes, mark any dependencies, draw your bars on the timeline, and bring it to every project check-in. That is so important because this has to be a habit throughout. If we don't keep this habit, we forget about it, and that's why we have engineering notebooks. We will, you're pretty much going to hurt yourself and hurt your grade. All right, that's all I have to say. It's been over 20 minutes, and hopefully you got something out of it.